Any discussion of Tesla vehicles will frequently bring up the vehicle's crash safety rating. Teslas are the safest cars in the world, which sounds great and is objectively advantageous to drive a car that is quote-unquote safe. However, I also remember hearing for the majority of my life that Volvo was the safest car in the world, and never once have I even considered purchasing a Volvo. How do we make this topic interesting and enticing? Can safety be cool? Obviously, we can show a bunch of crash test footage. Here's the thing, it's amazing that you can crash into things with the Tesla and not die, but there are many different things that contribute to getting there. From the design of the frame to the onboard technology to the software, Tesla really takes a comprehensive approach to making their vehicles as safe as possible. Since Tesla's safety measures are constantly being improved, learning about one of the features we discuss here could one day even save your life. Let's start with the basics. In the event of a collision, the structural components of a Tesla have two main objectives: protecting the occupant, which is a given, and protecting the battery pack, because if you survive the impact but then catch fire, that's still not good and is a slight disadvantage to the electric vehicle platform, even though I've seen data that shows combustion engine vehicles are about twice as likely to do so. This means that the entire front end of a Tesla has the capacity to crumple, and by collapsing in a very specific way, the structure of the car will absorb as much collision energy as possible. The bumper beam, a piece of metal that sits just behind the plastic bumper and runs parallel to the road, is the first line of defense. Moving on, there are two crush cans or crash rails on either side of the car, which are metal beams that run from the front to the back. These will collapse and absorb the impact of a low-speed collision up to about 20 miles per hour. After that, things start to get serious as the energy from the collision reaches the main structure of the vehicle. The new front Jige casting from Tesla has been specifically designed to absorb and then resist energy from a head-on collision. For the first 2 feet of the casting, 3 structural ribs run from front to back and are intended to crumple easily. However, as you move towards the back of the casting, you get progressively thicker levels of ribbing that are tied together with a honeycomb of triangular patterns. This section is much stronger, and this is where the Vest specifically designed their new front jig. This isn't the only line of defense built into the front end, according to Tesla, who terms it control old crushing. Multiple load routes through various crush structures that are optimized for various impacts have been set up by Tesla. The lower load path that sits underneath the casting will divert some crash energy into the subframe, and as the subframe crumples, it's actually designed to pull the front drive unit straight down and away from the rest of the vehicle, so you never have to worry about the front motor coming up into the cabin or getting pushed into the battery pack. The subframe crash rails are also set wider apart than the main structure, so if you hit something like a tree or a post with just the corner of the vehicle, that will be outside of the main crush can, but it will still get absorbed by the lower subframe load path. And that lower rail is set at an angle, so that as it is absorbing the crush, it's also pushing the vehicle away from the point of impact, so the cabin will be clear of the object by the time it passes by in the event of a really bad collision, where the impact makes it all the way through the front casting. This is the point where you want the car to stop crumpling and start holding its ground. Tesla creates its door frames, glass, and battery pack with a stiff construction that captures the energy from the crumple. The roofline, the strip below the doors, and the B-pillar that rises up in between the front and back doors on the inside of the Tesla have a skeleton structure made of ultra-high-strength steel. The middle layer is mostly made of the same ultra-high-strength steel with some aluminum and more high-strength steel. The outer shell is made entirely of mild steel. When Tesla performed their head-on crash test of the Model Y, this structure held up so well that they were still able to easily open the front door even after smashing into a brick wall, making the side structure of a Tesla vehicle incredibly strong and resistant to collapse. The roof of a Tesla Model 3 can withstand over 20,000 pounds of force, which is equivalent to having 2 fully grown elephants sit on the car at once, and is made of a very specific structural glass that works with the ultra-high-strength steel frame to support the roof. The battery pack in the Tesla car is also made for maximum safety. Like everything else, the battery pack's weight is probably the biggest benefit. By placing 1,000 pounds of battery cells beneath the floor, an electric car can have an incredibly low center of gravity, making it almost impossible for it to roll over. All Tesla battery packs are made to be incredibly rigid, but their newest design, the structural pack from the new Model Y, is the strongest yet and uses wide-diameter steel battery cans. If you examine the Sandy Munro destruction, All that is left is a single, solid brick. Tesla's fleet data is one key edge it has over the competition. Every single Tesla that is on the road has a full set of surround cameras and a powerful computer to process the video, so Tesla can actually use their in-car data to look at real-world conditions around all kinds of different collisions, because every crash is unique. The Tesla engineers want to make sure that they've taken all possibilities into consideration. Most people wouldn't realize this, but the interior of a Tesla vehicle is absolutely loaded with different sensors and cameras. The car makes all of these calculations within 10 milliseconds of an impact detection, and the computer will use all of that information in real time to determine how to best deploy the airbag bags for maximum effect. The car is always aware of where the seats are, where the steering wheel is, what's happening with the seat belt, and even measuring the weight of each person in the car and where they are sitting on their seat. The airbag system even contains active vents that may alter the bag's interior pressure depending on the impact angle, and these software-based safety measures are always being improved. Tesla continuously does fresh computer simulations and hands-on tests in their in-house crash lab to assist them fine-tune the airbags and seat belts for maximum safety. Recent updates to the automated system have improved it to the point where the vehicle will now begin preparing for a collision even before one occurs. Elon Musk stated at Tesla's most recent shareholders meeting that the best crash is no crash, and that the first real line of defense against a collision is Tesla's AI vision network, which is always on regardless of whether you're using autopilot or not. Those cameras can see when you're about to hit something or get hit, and the computer will actually pre-tension the seatbelts to make sure that everyone is held down before the moment of impact even arrives. Nowadays, every high-end automobile includes automated emergency braking and maybe some level of automated steering. These features can, to a very limited extent, act as collision avoidance systems, but by the time they engage, the car has already entered a dangerous situation. Tesla is developing an AI-powered technology that can actively stop the car from ever entering the danger zone. Tesla's autopilot uses something called an occupancy network. It's an AI neural network, and its job is to use the image data from the surround cameras to understand the environment around the vehicle, including the road conditions, and all of the other cars that are sharing that road. This AI is not only recognizing where everything is in three-dimensional space and identifying what everything is, but it's also making predictions about where all of these things are going to be in the future. Using that 3D map, the car can plot out all of the danger zones on the road. It knows that if it enters any of those areas, there will be a high likelihood of a collision, so now it can plot a course through the road environment that actively avoids even the possibility of a future collision. And the car can do this much better than a person, yes, even you. And that's simply because the car can see in every direction at once. And the technology just isn't there yet. Obviously, there are still plenty of situations where the human has to intervene to prevent autopilot from crashing itself. But we could get to a point in the not-so-distant future where it's more likely that autopilot will intervene against the human to prevent them from crashing the car. Don't forget to give this video a thumbs up today if you liked it. That is so important for getting our content out to more people.